Hello everyone again, this is Oz. So before we talk about the comparison of CFL bulbs versus ILB bulbs in terms of purchasing cost, now in this tutorial I would like to make calculations for energy cost comparison between these two types of bulbs, and at the end I will try to understand which bulb is better when we consider both energy cost and purchasing cost, and what would be the annual savings. Okay, let's get started. So we have a few different pieces of information that we need, and one of them is inflation rate for energy per year and the conversion rate from kilowatt hour to kilowatt to watt. Okay. So 1 kilowatt is 1000 watts, and inflation rate for energy is given to be per year base 3.4%. So now then let's calculate under our calculation column, let's calculate the inflation rate for energy, not energy, per period, not year, per period. Okay. So again, our inflation rate per year, 1 plus, and the power is the period length, which is 0.822 that we calculated previously, minus 1, which is 2.79%. So now I can calculate energy costs of CFL and ILB. So again, let's write the periods from time 0 till 8. Okay. And energy cost per kilowatt hour. So I know that currently the price of energy is 15.5 cents per kilowatt hour right here. But I know that also there is inflation that will impact the price. It will always increase based on the historical data in this question. I multiply G28 times 1 plus formula on page 14 again. Not interest inflation rate per year, inflation rate per period. So I can fix this one because I will use the same cell again and again. I can now copy my formula to find the future prices. As you can see, the price is going to increase from 15.5 cents per kilowatt hour to 19.3 cents. Now let's calculate, next step, energy used by each type of bulb. So CFL energy used per period So I know that a CFL bulb is using 13 watts of energy per hour. Okay, so I need to divide by 1000 to calculate number of kilowatts is used per hour for CFL bulb, times I need to know how many kilowatt hours we need overall. So we are using each bulb 4 hours a day, times we have 5 rooms, 5 bulbs in a room, times we have 300 rooms in each hotel, times we have 14 hotels in our chain. Okay, so as you can see here, we have an issue. So the issue is, so we calculated all these things, but this is for only for 1 day, because we multiply 4 times and 14, 305. But also we know that every period has 300 days, right? So I need to multiply by number of days as well. Okay, so this is how much energy that I will use per period if I have CFL bulbs. So to make it simpler, we could use, instead of multiplying with all this, we could just multiply by number of bulbs needed as well, which would give us the same result, which I made a mistake here, just a second. But I still need to keep C9, which is this one. So I could delete this, which only gives me number of bulbs needed. So I could just directly put number of bulbs needed here and get the same result. Okay, this is how much energy I need if I have CFL bulbs per period. So I would like to copy paste same information here, and I know that my energy use will be always same, right? Because I will have same number of bulbs, I will have same energy usage per bulb, and I know that I will have same number of hours per day, and I know there are same number of days in a period. So I could highlight all this and push F4 to fix the formulas, and now I could copy paste the formula. So what I want you to notice that I kept the first cell empty. The reason is that it's assumed that we first use the energy from the beginning of the period, and then we will make the payment at the end of the period. So this money right here is the money that we will pay as energy cost at the end of the first year, okay? But again, to make things consistent with the cash outflow cost structure, I just put minus in front of them so that all of my cash flows are negative, they are costs, okay? So let's make the similar calculations for ILB bulbs. We need to first calculate how much energy do I need for ILB bulbs. So ILB energy use per period. So this time, again, I consume, instead of 1360 watts, which is by dividing 1000, we will find how many kilowatts we use, times in each day I'm using an bulb for 4 hours, right? And I have 300 days in a period, and I know that I need 21,000 bulbs. This is how much energy I need. By the way, I realize that there is a mistake here. This is energy used. This is not money. So I will put negative sign once I calculate my cash flows. Okay, which is everything the same. It's just positive versus negative. So this is just energy used. That's why I kept it positive. Again, I can fix my formulas because I will use the same formulas again and again, and the energy use won't be changed. Okay, perfect. Now I need to calculate my Cfl energy cost. Which is Cfl cash flow in terms of energy cost. Excuse me, and ILB cash flows. So I know that for Cfl, I will use this much energy per period times, I know the cost of energy will be this much, right? But this is my cash flow. So since this is cost, I will put negative sign in front of it. Excuse me, so I have allergy today. I can just copy paste the formula. I will do the same thing for ILB. I know that energy cost is this much times I need this much energy. Again, I will put minus sign in front of it to show cash outflow. And copy paste them. So again, these are not net present values. These are just cash flow. So I need to find net present value. So NPV, energy cost for CFL. I will make this one green because this is our model output, one of the model outputs. Excuse me, and ILB. Okay. For so CFL, I can use NPV function that we covered in the class. I can choose all the cash flows, but first I need to choose my rate. As you can see here, so my discount rate is, as we calculated before, 6.53%. Now I can choose all my cash flows starting from at the end of the first year, which is year one, in this case, period one, sorry, and all the way down, right? 8 periods, so I just close and calculate it, which is more than $346,000, almost $347,000. And let's do the same calculations for ILB, but this time let's use formulas, financial and NPV. It asks our rate, which is our discount rate right here. Enter. And it asks our values, which I have cash flows for ILB right here. Enter. And OK. So you can see here that ILB in 8 periods will cost us more than $1.6 million in terms of energy used, right? So we know that it's cheaper to purchase ILB bulbs, but at the same time we saw that with our energy cost calculations that ILB is really expensive in terms of energy cost. So now let's try to calculate the total cost. That is the summation of two costs, energy cost and the purchasing cost. total cost. Can copy paste the period information again. So for CFL cash flow and ILB cash flow. So I can sum all the cash flows that are under purchasing costs here, plus all the cash flows for CFL right here. Okay, I can just copy my formula. Oh, there's one mistake here. As you can see here, we are summing with energy use. I don't want to sum up with energy use, I want to sum up with CFL cash flows in terms of energy costs. Okay, so now I can copy paste the formula. So this is the cash flows for CFL, and let's do the same thing for ILB. ILB cash flows in terms of purchasing costs, we calculate right here, not MPV cash flows, plus ILB cash flows right here, starting from 0. Okay? Okay. So as you can see at the beginning, CFL was more expensive, but year by year afterwards, ILB is more expensive. So let's calculate now MPV values for both of these options. Excuse me, I really need allergy medicine. Not energy, this is total cost. So, which is NPV, our discount rate, comma, all the cash flows, not including 0, as you remember. But then we need to add the 0 at the end, not in the MPV function. Okay. Let's do the same thing for ILB. I copy pasted the formula. So I just need to make sure that I'm referencing to the right cells. Okay. So you can see here that when we consider both costs, ILB is much more expensive than CFL. So if you wanted to annualize these costs, we could annualize costs for CFL and ILB. So I could divide this MPV by number of periods, which is 8, divided by period length to make it year, right? So per year, just divide. It costs $65,000 and $65,545. And if we annualize ILB costs, this divide by number of periods, divide by the period length, which you can see here, it's $254,000. So if I ask you, what is the annual savings? Your answer would be this minus this, okay? So if you go with CFL, you would spend $188,611 less. Okay, so thank you so much for your attention, and I will see you in class. And if you have any questions, please send me an email. I will respond you as quick as I can. Okay, thank you.